this is the first day announced by United Nations. It is announced very, preparation time was very less, but I thought being School of Environmental Science, we have to celebrate it for the benefit of our students. We have to invite the personalities, renowned contributors, policy makers who have done great job for environment, clean air, or those who have been associated with air pollution, clean air campaign. I am very lucky and very glad that Professor Jayaraman, former Director NARL ISRO, Dr. Jaya Sharma, former Head ONGC Environment, Professor Ishan Kumar, Professor in SES, Dr. Samia Singh from Texas, and Dr. Usha Nina, they have readily agreed to share their thoughts, give some capsule feeding to the students about clean air, how to maintain, how to conserve environment. And this program is basically conceived by YoHo, Young Holistic, which is outreach program which started in JNU-ENVIS. Young Holistic program basically is a part of holistic environment approach that is sort of integrated solution providing for environment. That program has been started. Part of that we have outreach program that is a Young Holistic having 30 activities, positive activities which provide holistic development of the student. Holistic means physical, mental, psychological, philosophical, and spiritual development of the student. There are activities, for example, quiz, debate, synthesis, abstracting, expanding, writing, all these magazines. All students of PhD, mostly MSc PhD, they are leading these activities. And then ENVIS, we have ENVIS Center, Ministry of Environment and Forest, Climate Change. So that also share this occasion. So with these words, basically I welcome all of you, all audience, all the contributors. And once again, very good morning. And I will now one by one introduce when speakers turn comes. And then I request all panelists to limit for 10 minutes and few minutes for discussion so that it will become interactive. That becomes very interesting for a student if it is more interactive. So with these words, I welcome Professor Jayaraman, who has been, I have seen him aerosol brand since beginning, and the Yasta on his foundation came. Professor Jayaraman was working on aerosol radiating forcing, sky, satellite, or so I thought, and I was also working with him for many decades basically, and I thought of inviting him. Professor Jayaraman was working earlier as scientist at PANELIST Ahmedabad, and then he was picked up as director National Atmospheric Research Laboratory, Gandaki. And then he had contributed a lot of on radiative forcing, aerosol, ozone, all these atmospheric. He was very veteran in Indian Ocean Experiment, and then he was part of sort of co-PI of atmospheric Ramgrad project. Also, lot of work he has done on physics of aerosol, air quality, aerosols, and what you call monsoon related things also, and some transport issues also in this region. So with these words, Professor Jayaraman, please. Professor Jayaraman.
Yeah, please. Yeah. Oh, okay, I see. I can start with my presentation, is it? Okay, fine. Yeah, good. Okay. So first of all, thank you very much, Umesh, for your kind words. So I have a few slides. As I said, I will limit it within 10 minutes. And then, of course, we can have some discussion also. So let me just start sharing my slides. I hope I can do it now.
Okay, by the time it comes, because it takes, loading, it takes time. I gave some example. By the time it comes, everybody can see, and I will stop it. That the clean sky, what we are seeing today, it's due to global lockdown. But before that also, 1819, Delhi has seen clear sky because of EPCA action. EPCA took stringent actions to control these illegal factories, control plastic burning and the pyrolysis factories, which gives tire oil. And because of that, smoke in Delhi was controlled. Visibility was increased, and we have photographed, we have published in our newsletter. So all this was a small model, but the corona lockdown has given bigger model, global model of that industrial shutdown gives clean air. So if we want to cope with clean air versus industrial development, we have to think of non-polluting machinery, non-polluting energy sources, that kind of thing. We have to switch over. This is the message, and we should follow it. Hopefully that slide is coming or what?
Yeah, Umesh, can you see it? I am showing the slide. First slide.
No, it's not showing. When you share that, it should come. Jayaraman is showing the slide as this message comes.
Is it? I am sharing, but the screen.
You have to share entire screen.
Yeah. But actually, Chrome wants to share the content. I think.
No. You share the entire screen.
No message is coming. Anybody?
Now probably you should be seeing
yes. Now it will come.
Yeah.
So now you can continue, Professor Jayaraman.
Yeah, now you are seeing the slide?
Yes.
It's coming.
Good. Thank you, Umesh, once again for inviting me for this meeting. So I have I like to share my whatever I learned a little bit about this and how to make about this clean air and aerosol business. So I will limit it in 10 minutes. So let me start with one of the recent data. What you are seeing here is the so-called aerosol optical depth. Yeah, it's measured with an instrument known as MODIS, on-body and NASA satellite, 2 satellites, of course. So what you see is the aerosol optical depth indirectly gives the columnar aerosol curtain depth. So if you see, of course, Umesh mentioned about the recent one. I am coming to it. So these are all these 2016, 17, 18, 19. And then when you come to 2020, you see here the optical depth has gone down. See, this is the optical depth values. Suppose if you say aerosol optical depth less than 0.25 or 0.1 or even less, then only we can achieve the blue sky. Typically, our values are in the 0.5 region, or it can be even more in some region. But this is what happened in the last 3-4 months. Yeah, of course, there are some places, this is the difference, You mind the average of the last 4 years versus the present one. This is the difference. So, particularly, you see here the Gangetic plane. So, this clearly shows the only difference is that human activities have almost come to a standstill, mainly the polluting kind of things. So, this gives us the message that why the sky is not blue means it is our contribution. We are not making it blue. So these are all so when we talk about aerosol, there are several types. It can be from organics, it can be from dust, or the sea salt. They are all naturally produced aerosols, and we cannot do anything about it. They are part of the ecosystem. But the one which is from the industries, automobiles, and this biomass burning, So some of them are entered as a gas and then converted into particles like sulfur dioxide going to sulfate, oxides of nitrogen, nitrate, etc. And soot particles are black carbon, they are directly injected into the atmosphere. So we are concerned about aerosol for two reasons. One, of course, is the human health. So when we are talking human health, these are all the aerosol characteristics we should know. That is, first is, of course, the concentration in terms of mass or number microgram per meter cube. What are all their size, because it depends how much we inhale, and then the chemical composition. But to get this, we need to deploy instruments. Mainly, they are in the surface level with these monitoring stations. But only thing is that we need a large number of stations and to get these the numbers. But the other one we are concerned about aerosol is for the climate studies. But when we talk of climate, there are the characteristics we should know is the list is big, like aerosol optical depth, single scattering albedo, which gives the aerosols how much it is absorbing and how much it is scattering. Asymmetry parameter is how the scattered radiation is distributed, or the scattering function, forward versus backward scattering. And then, of course, it can be actually measured, or it can be computed theoretically also. If you want to do computation, then we should know the refractive index of particles, their chemical composition, their size distribution, etc. Just let me share one data which we have been doing earlier. See, this is the aerosol radiative forcing, and I have combined all the data into this simple block. This is about some 6 to 8 years of data going into this. By aerosol radiative forcing, what we are meaning is that, of course, for a climate to be normal, we need the radiation budget to be maintained. But if there is any deviation in the radiation budget, we call it as radiative forcing. So these are all the 4 blocks for the 4 regions. And if you see, these numbers are all the watt per meter and the actual solar radiation in terms of watt per meter square. So with the presence of aerosol, if you concentrate on the bottom value, this is the radiation which we are missing. That is, aerosols are responsible for removing, say in Arabian Sea, 27 watt per meter square. Within peninsular India, some 27 watt per meter square. Here it is 34. Here it is 23. This much radiation is missing because of the presence of aerosols. Then we can compute how much is going back. See, these are all the numbers. See, in case of scattering it is normally considered that scattering is conservation of energy. It is just a redistribution of energy. So whatever we are missing at the hemisphere, bottom hemisphere, should be compensated from the radiation going back to space. But when we did the measurement with, again, with the satellites and the computation, etc., these are all the kind of numbers. See, plus or minus 0.5 error you can take, but these are all the ballpark numbers. You see, only 7 is minus 8, it's going out. Here it is only around 5, 9, 7. So while there is a big loss, they are not really going back to space. So this is the main thing which we learned. One is, of course, the forcing itself. Then we learned that there is a huge portion of radiation is missing, or actually it is being absorbed or trapped within the atmosphere. So these 3 blocks are what is missing in the surface, what is going back to space, and what is trapped within the atmosphere. Okay, these values are slightly high. As it's for dry season, January, February, March, April. So actually, Bay of Bengal is still more polluted than our peninsular India, because the Gangetic Plain and even the winds coming from the northeast region. So this is more polluted. But as you go to Indian Ocean, they are relatively better. But of course, we can go deep down. We went up to down to Mauritius. So we can really see the blue sky there. So I was talking about the absorption. Then we started looking for the candidate, and the candidate is now other than black carbon. So what is black carbon? Black carbon are soot particles. It can be emitted from forest fire, open biomass burning, or from incomplete combustion of fossil fuels like diesel, petrol, kerosene, and coal. So again, there are 2 major contributors, as I have shown in the earlier part. So one is from the burning of agricultural wastage, and another is the industrial. This is mainly the fossil fuel like coal, kerosene, whatever fossil fuel burning. Here it is purely from the biomass burning. Here also we had, when we did, we started working on this. I want to study how much the capability, how much they are absorbing in terms of quantitative number. Again, there was a surprise waiting for us. This is the absorption coefficient, yeah, normalized absorption. They are normalized at 950 nanometer. This kind of measurements can be made using instrument like PSAT, particle absorption photometer or ethalometer. Of course, anybody interested in detail, we can discuss later. But when we studied, we actually took our instrument. One is close to this kind of leaves and dry leaves, agriculture waste burning, what the spectrum like this. Another is this diesel smoke, like this. See here the large difference. So this biomass burning, the soot coming out from the biomass burning has large absorption compared to this black hole. They are, of course, both are absorbing, but this is still more intense absorption. And particularly in this region, this is what our solar radiation comes into the earth, and this is what is getting trapped within the atmosphere. So this is what the standard diagram, many of you might have seen. This is the radiative. This they published by this IPCC, Intergovernmental Panel on Climate Change. So if the forcing is zero, means this is a normal steady state condition. That is, the Earth's atmosphere is in radiative equilibrium. That is how much radiation is trapped within the atmosphere is radiated back as infrared radiation. But when this radiative forcing is the deviation from with respect to the balance. So we know that CO2, methane, chlorofluorocarbon, nitrous oxide, they are all contributing to the positive forcing. But when we are talking about aerosol, always you see it goes from both positive and negative. So, for example, sulfate particles, mineral dust, nitrate, they are all basically, including even organic carbon called OC, they are all scattering aerosols. So they actually scatter back to space and they can balance to some extent the radiative forcing caused by the greenhouse gases. But this black carbon, you see, this is large. As uncomparable to, say, for example, the methane. In fact, the earlier diagram, if you see this is shown as our level of confidence. We have really now high level of confidence about this values, about the absorption. And I want to tell you one thing. See, this diagram is for the global average. So average itself is this. But as you can see that this soot and all are produced inland, and particularly countries like India, the contributions are more. So if you plot this for individual countries or individual region, this can be quite big, much more than even the carbon dioxide itself. That is the question now we have to address. So let me say a few quotes and then I will conclude for if there is, we can take it up discussion. So IPCC report says that we are already started seeing the consequence. This 1 degree is already there, happen, and of global warming. So we are seeing extreme weather, rising sea level, diminishing Arctic ice, like many changes, like ecosystem change, migration of birds, the biota, etc. And the way things are happening, with about 2 degree warming per decade is also very soon we are going to reach 1.5. Why? The estimate is we will be reaching 2 degree warming by about 2040 to 2050 region, a year period. So that is really alarming if you do not take any action. So then, of course, always the question asked is that how this climate change is affecting our Indian monsoon. There are several studies are going on, modeling studies, both in India as well as abroad. Many people are doing simulations. So I like Andy Turner, who really summarized it. So he says that simulation of future climate generally suggests an increase in monsoon rainfall on a seasonal mean area average basis. See, when he mentions here, he mentions monsoon, not just Indian monsoon. He says the monsoon is a belt, the intertropical convergence zone. So, of course, India gets maximum, but the belt extends up to even Korea, to Burma, to even some southern parts of China. So, monsoon is a big system. And, of course, when there is a southwest monsoon, northeast monsoon, so they are mainly a tropical phenomena. And global warming, yes, it suggests that there should be an increase. But also show different patterns on rainfall change. It is difficult to predict how rainfall might change within India. So this is kind of an average picture, but when you are Indian specific, still there are so many references we can quote. Some say yes positive, some say it is negative. So that is on a regional basis, of course, India basis, and if you again go into regional basis, there are somebody say, no, central India will get more rain, or this Gangetic plain, or southern India will affect all kind of things. So in India, it is the variability of rainfall on shorter time scales that has the biggest impact. That is intense heavy rainfall leading to flood or break in the monsoon. Normally, the monsoon break we got. It can be a week or more due to water. It can lead to water shortage and approval for the start. So it is not, we are no longer interested in the average one, global average, or even for that matter, Indian average. No, we have to go into this specific region. So why it still continues to be difficult? Because the main culprit is the aerosol itself, incorporating the aerosol variability. So let me conclude by quoting the one from the World Bank. Climate change is an acute threat to global development and our efforts to end poverty. Without urgent action, climate impacts could push an additional 100 million people into poverty by 2030. That is the World Bank says today. So let me anyhow end with this last slide with a positive note. So Government of India has already have taken the action. It is known as the National Action Plan for Climate Change. And there are several, about 8 missions are there, like solar, National Solar Mission, Mission for Enhanced Energy Efficiency, and so on, so on. And Sustainable Agriculture, Strategic Knowledge for Climate Change. And that. So, of course, the government has done its part. And now I think it is the duty of scientists, and we need to work on this to see that these things are happen in a sustained way for a future blue India. Thank you.
Thank you, Professor Jayaraman. Wonderful research findings shared by you. And I take the message that there is a lot of work, challenge for scientists to do research on monsoon, rain patterns, and also, in my opinion, rain quality, because the pollutants are deposited on the ground and they spoil various water and other systems. And meanwhile, I welcome Professor C.K. Vaste. Good morning, sir. He has joined. And then we have to work for climate action and other 8 action what Professor Jayaraman has highlighted. With these words, I once again thank you very much. And now I welcome Professor Jaya Sharma, our another eminent scientist. Professor Sharma is a STA fellow from METI government of Japan. He is member of Appraisal Committee of EAC2, Ministry of Environment, Climate Change and Forest. Then he is a member of DVT Expert Committee on Environment Biotechnology. He is member of QCI NAVIT Accreditation Committee. He is former chairman NGT Committee on Pitless Drilling. And he is former head environment ONGC. He has so many things, 38 years of experience, but he is also chairman of Indian Association for Air Pollution Control. So he has several responsibility, I would say. He is continue, and then he is inspiring the young people to do more research, and his area has been more towards chemistry. So without wasting much of the time, now I welcome Professor Sharma. Please.
Good morning, Professor Kulshrestha, introducing me, and good morning to Professor C.K. Vaste, our guru, and good morning to learned panelists. And it was very excellent presentation by Dr. Jayaraman. Let me start. I don't have the presentation because Professor Kulshrestha said it is not required. But anyway,
no need more time like the uploading, man.
Yeah, right. So International Day of Clean Air for Blue Sky, as notified by the UN, they have also announced the theme. The theme for 2020 is Clean Air for All. This is the theme they have announced. And this decision they have taken on December last year, 19 December 2019 at 74th session of the General Assembly, wherein they invited UNEP to facilitate the observance of the International Day in collaboration with other relevant organizations. And it aims that it raise the public awareness at all levels, individual, community, corporate, and government, that clean air is important for health, productivity, economy, and the environment. It must demonstrate the close link of air quality to other environmental development changes such as climate change and global sustainable goals. It also aims to promote and facilitate the solutions that improve air quality by sharing actionable knowledge, best practices, innovations, etc. It must bring together the diverse international actors working on this topic to form a strategic alliance to gain momentum for concerted national, regional, international approaches for effective air quality management. So the situation of air quality is very much alarming, at least in India, because we have low cost in the air, corona on the ground, earthquake beneath the surface, and increasing frequency of cyclones on both the coasts. This clearly indicates that something somewhere went wrong with our ecosystem that needs to be fixed before it is too late. Vandana Shiva, the noted environmentalist, also said, humanity finds itself confronting pandemic and climate change. Other fact sheets on this, if I want to narrate, 7 million premature deaths due to air pollution globally. There are 91% world population lives in places where air quality level exceeds from the prescribed level, and the impact likely on the health because of invisible particles as highlighted by Professor Jayaraman, ground level ozone leads various kind of health issues. Then short-lived climate pollutants like black carbon and methane, they also causes the different issues of air quality. Then the agriculture waste burning disposal is also a major issue. The other critical issue which needs reform, at least in our country, is critically polluted areas, then severely polluted areas, then other polluted areas, and about 122 non-attainment cities based on extensive monitoring as identified by the Central Pollution Control Board. Then if you see the blue sky concept has come because after a long time we realized that the sky has become blue because of the pandemic. There was no movement, industries were shut down like that. Then people realized in our student time, usually the question was asked, why sky is blue? But over a period of time, this question never been asked in any competition in any classroom by the teacher. So, but the Chennai, Ahmedabad, Bengaluru, and Ghaziabad is the quality of air is become better during this pandemic time all across the India, even including the Los Angeles, New York, Beijing, Seoul, and Milan. They have also experienced less pollution too, hit hard by the virus restrictions on the people movement. Then NASA also, in the European Space Agency, satellite imaging confirms a significant decrease in nitrogen dioxide pollution. A similar effect has been reported from the northern Italy, and air quality index has come down to record levels. Across the Atlantic, New York scientists at the Columbia University reported that 5 to 10% drop in CO2 emissions during the mid-March and April. So the visibility of clear blue sky is there, it was there, and gradually this may go if we do not take the appropriate action in place. So we have learned a lot of lessons actually out of this. It is possible to achieve cleaner air when fast and decisive actions are taken. It is possible to have our blue sky back if we cut down fossil fuel emissions across all industry sectors. It is possible to live in a way that creates less pollution on an individual level, travel less, ride a bicycle, or walk short distance, work from home if possible. Then for the air quality movement, the air quality improvement, there are fast-breaking steps taken by the government. For example, we have jumped to the Bharat Stage 6. This leads to reduction in nitrogen oxide, hydrocarbon by 70% in our atmosphere. then particulate matter reduction by 50%, and the fuel is available since April 2020, and PSU refinery invested 35,000 crores in Indian rupees to reach to do this cause. We have Government of India has also announced biofuel policy in 2018, where 2G ethanol, second generation ethanol has been set to produce, and Indian oil, HPCL, BPCL on agro base without sugarcane blending is permitted up to 20% by 2030. With Dahej, Bargrain, Odisha, Panipat, Bhatinda, NRL, there are 5 plants are expected to be set up in this area to produce the 2G ethanol, and already the 5 crore 3 cylinders of LPG were distributed as a part of the improvement of the air quality issue. Then compressed biogas is also being planned. The estimated potential government has estimated about 62 million metric tons. So they want to produce from the municipal solid waste in biomass, and this will improve the methane reduction and other associated secondary pollutants. Then there is a big natural gas hutch is permitted share to increase from 6% to 15% by 2030, and the renewable energy, we have a target of about 175 gigawatts of renewable energy. In Paris 2015, again, 83 gigawatts has been achieved. The Prime Minister has subsequently increased the target 450 gigawatts at COP25. We have reduced the emission intensity of GDP by 21% from the promised target of 33%. Then there are some certain incentives for the electric vehicles. Taxes have been lowered by 12%, along with the several other incentives offered by the e-vehicle manufacturers. Then use of hydrogen to deal with the nuclear air pollution in the pipeline. Then critically polluted area, we have come out with a notification about green belt increased by 40% and certified emission reduction to double, just to increase the quality of improvement, quality of air in our atmosphere. Then we have also taken certain initiatives in the thermal power sector by fixing the PM10 load, sulfur dioxide and oxide of nitrogen, and this will cut the PM10 level by 40%, and there are other associated benefits. Similarly, for fly ash also we have taken. So it is the time to say goodbye to air pollution. When we can breathe clean air, we must remember that it is possible to have cleaner air. It is possible to have this again even without a lockdown, only if the people and decision makers actively practice without we have learned over the past few months, can maintain cleaner air even after the pandemic while stimulating the economy and tackling climate change. But we must focus on green recovery, reforms in current energy system, make green and public-friendly transport system, strengthen the air pollution regulation, especially the enforcement system. So our way forward in last slide is the current crisis has shown us that clear sky, blue sky, breathable air can be achieved very fast if concrete action is taken to reduce burning of fossil fuels, strengthen the monitoring network, check on the ozone level rising, energy and industrial structure to be upgraded, control over VOC and PAC is to be taken care. Plus, especially for Delhi, we have about 6,000 clean work around the Delhi. So that also need to be seen in producing the bad air quality contribution for the Delhi. So we need to see all this. With all this, I thank and I stop here. Thank you.
Thank you very much, Dr. Sharma. Very nice, very informative lecture, and I think you have really said what we need to do to go with the balance between the development and environment. That is a really challenge for government and also for researcher and policy makers. Now, I welcome our another panelist, Professor Ishan Kumar. School of Environmental Sciences, Professor Ishan Kumar is a School of Environmental Sciences product. He has served at different universities. His area is also aerosol and noise, so very much related to clean air. Lockdown scenario, he has some work done, his student or group has done some data analysis related to that. He has been always, having concern about clean air, physics of aerosol, chemistry of aerosols. He is involved. So many publications he has done. He is associated with several organizations, Board of Studies and UTC exercises. Vast experience and his maturity in the field gives us, a feeling that on this occasion he is the right person to say what our school has contributed in terms of aerosol science, visibility, and noise pollution. So, with these words, I welcome Professor Ishan Kumar. Ishan Kumar, please.
Thank you, Professor Kulshrestha, and good morning to all the distinguished panelists, Professor Jayaraman, Professor Jitendra Sharma, and my guru, Professor C.K. Varshney, who has taught me ecology when I was a student. Well, I'll just like to extend where Professor Jayaraman had left us, that when we basically this Blue Sky Day, the main idea behind celebrating this Blue Sky Day is to focus on air pollution. And one of the dimensions Professor Jayaraman spoke in a very elaborate manner on the effect of air pollution on climate change. The other two aspects are the implications on human health and the implications on agriculture also. So, Indo-Gangetic Plains is a region where the air pollution induced mortality is very high. And already there are some studies which are also suggesting that the solar dimming caused by the haze may be responsible in reducing the crop yields. So these are the other two dimensions that we need to look into. But today I'll just share with all of you the results on pertaining to Indo-Gangetic Plains, which are not exactly on aerosols, but the source of that pollutant is also a source of aerosols. So from that perspective, but one thing before I share my presentation with you is that clean air may not always, polluted air may not always lead blue sky. Sometimes if the aerosols are missing, it is the aerosols which are responsible in giving the blue sky color. That is the changing the color of the sky. Say normally when there are no aerosols or AOD is very less, we get blue sky because of the preferential release scattering by the molecules in the atmosphere. And when aerosol particles are present, then the me scattering also dominates, and then we get this kind of whitish hazy appearance in the sky. So, but sometimes like pollutants like carbon monoxide, say for example, it is a colorless gas, so the atmosphere may be polluted, but yet it may look like a blue sky. So I will share with you some of the results on what we had done about carbon monoxide. I'm quickly sharing those results with you. Is my
Yes.
screen
Coming.
Yes.
Yes.
So this is this shows the carbon monoxide gradient over the endogenetic plane uh, uh, taken from the MoPET data. So if you see, there is a gradient from the eastern IGP to the western IGP, the carbon monoxide concentrations being higher on the eastern IGP. So this is the gradient that persists almost in all the seasons, though the intensity, the carbon monoxide concentrations may vary from different season to season. Say this is for winter, pre-monsoon, but the gradient always persists. So the objective of our work was basically to identify the exact cause of this gradient. Actually, this has not been investigated. It had not been investigated till now. So we, well, this is the time series plot for from January 2003 to January 2003 to December 2014. So here also you are seeing that this eastern IGP always has. So this is for both the satellites, carbon monoxide data from AIRS as well as MoPET. So we see that the eastern IGP always has the higher carbon monoxide levels, both in MoPET and AIRS. So this is the typical seasonal plots that we got, that during the monsoons the carbon monoxide levels were lower, but again over here you see this red color shows the eastern IGP. So the carbon monoxide levels over the eastern IGPs were always higher in all the seasons. So this is a vertical profile plot, which again shows that the eastern IGP is having higher carbon monoxide levels than in the upper atmosphere. You can see that this is during the monsoon month. You see that there is some conventional transport of carbon monoxide in the upper atmosphere also at 200 hectopascal level. So, well, we wanted to see that this is the plot between rainfall and columnar carbon monoxide. So we saw a negative, even though the carbon monoxide is not very soluble in water, but yet some scavenging seems to take place, and we got these negative trends in all the IGP regions. Now, we wanted to, well, this is the enhanced vegetation. I won't speak because this does not have much to do with this. Rather, I'll share with you. We wanted to investigate whether the crop yield, the crop residue burning after the harvesting season has anything to do with this spatial gradient, and we found that the fire count data, the number of fire counts are more over the western IGP than the eastern IGP. So, I mean, if this is the reason, then the gradient should have been the other way around, that is from western to eastern. So, the crop burning after the harvesting season, that cannot be the reason for this existence of spatial gradient over the IGP in carbon monoxide. Then we also did some trajectory analysis, and we also found that the trajectory analysis also did not explain the spatial gradient that we observed in carbon monoxide. So we also, in fact, made comparisons of fuel consumption in LPG, petrol, and diesel. So here also we found that the fuel consumption is more on the western IGP. So this also did not explain the spatial gradient in carbon monoxide. And similar story was for the coal consumption also. the coal consumption differences are also not that pronounced, so which could not explain. So then actually we had done some study on, one of my students had done some study on air pollution emission during household cooking. So I realized that in that work, during the cooking cycle, the carbon monoxide levels reached very high. So it occurred to me that quite possible that the household cooking may be responsible for this, and my hunch was correct. So, well, this is what we had observed, that the carbon monoxide concentrations during the cooking cycle were very high during different kinds of fuels. So, when we looked at the household density distribution for different cooking fuels, the story became evident. If you look at this plot, we find that the biomass-based fuels, their use is more prevalent in the Eastern IGP and than the Western IGP. Western IGP, it is much less. So this is what I want to say, that the biomass-based fuels are used in our villages morning, afternoon, and evening for cooking purposes, and this is a major source of emission. So, and not just carbon monoxide, but it also emits aerosols also, the soot particles which Professor Jayaraman was talking about. So, now if we compare the LPG penetration, on the other hand, the LPG penetration is more in the Western IGP than in the Eastern IGP. So you see that the gradient is opposite. So the cleaner LPG is a comparatively cleaner cooking fuel as compared to the biomass-based fuels. So the Western IGP, the penetration is more than the Eastern IGP and the Central IGP. So then we went on to actually estimate the emissions of carbon monoxides, from these cooking fuels for the different states existing in the Eastern and the Western IGP region. And the story became very clear that the Western IGP, the emissions are much less for the year 2001 and 2011 for both. So here it is of the order of 10 to the power 12 in the Eastern IGP. Here it is of the order of 10 to the power 11. Emissions and carbon monoxide emissions. So now the climate co-benefits, if we look at the strategy of the Indian government, that the Indian government is now pushing for the Ujjwala Yojana, pushing for deeper penetration of LPG among the poorer sections of Indian society. And this is one of the major reasons for this is to tackle the problem of health of the cooks, that is predominantly females who are doing this household cooking and using unhealthy fuels. But it also has its climate co-benefits, as it is also the source of emission of soot particles and black carbon. So, well, this is the comparison with Intergovernmental Panel on Climate Change default uncontrolled emission factors for residential fuel combustion. So this is for different this thing. So here, if you look at the gas, it is much less, whereas for wood, dung, and other biomass-based fuels, the emission of carbon monoxide is very high. So, well, this plot also shows the contribution of global warming potential for various fuels. So, the fossil fuels, it is very high, but if you look at the gas, it is again very, very less. So, and For biomass-based fuels, of course, this is much more. Well, so on this, based on this, we published this paper that carbon monoxide variability and its association with household cooking fuels consumption over the endogenetic plains. Well, this is what I wanted to share with you. I'll now stop presenting, and I'll be very happy to share any to discuss my study with all the participants.
Thank you very much, Professor Ishan Kumar. If any comments are there, we will convey and we will discuss this later.
Yes.
Now we have next panelist, Dr. Saumya Singh. Saumya is young budding scientist in air pollution, atmospheric chemistry. She has done PhD from School of Environmental Sciences, from our school itself, and she is my student. So I thought of, because encouraging young student, and she is working for, she has worked at the University of Toronto Chemistry Department. Now she is working in Texas, and she is now soon going to University of Berkeley. So, because, charity starts from home, from that angle, I invited Saumya to encourage. It's a young holistic platform. So, from these words, Saumya, I welcome you. Please speak what you have done, what you see in future, and how to lead the sustainable society, because it is up to you, young researchers, who can do justice for this earth, planet. Thank you. Saumya, please.
Thank you so much, sir, for giving me this opportunity and platform to talk about. And hello to everyone, and especially to all the senior panelists and KK sir. And it's great to see you all.
Welcome, Saumya.
Thank you, sir. Sir, I have actually quickly put together the slides now because I saw it would be easy to talk about the work on slides. So I just wanted to share. Isn't now.
Come. Only one screen you click.
Okay.
आ रहा है.
Hi, sir.
Click. अभी तो नहीं दिख रहा.
No, it is not visible to us right now.
Click करो उसको एक ही.
Share your entire screen.
Entire screen share करो, फिर वो अपनी slide click कर देना. अभी दिखा नहीं रहा है. आएगा. Very good.
So can you see, sir, now?
Yes.
Is it visible, like my slides?
Yes.
Very good.
Okay.
Clear sky की तरह है.
Okay. So my slides, I will start from the, so as you all know, sir introduced me. I'm Dr. Saumya, and currently I'm working as a postdoc in the University of Texas, and I have worked in the University of Toronto and did my PhD from JNU. So I just quickly put together this slide during this session, and I could not agree to put the blue background on this. So, giving the sources we have in our country, like various heterogeneous sources. So I'll jump into my presentation and a quick intro. So I'm not going to talk about what is clear sky day, as all the panelists already talked about. And we also know that the reduction in air quality we are observing, we are seeing, these are because of the activity like lockdown activities and shutting down all the anthropogenic major activities we had in lockdown time. So I really like this like red line which I'm showing on from the World Bank website, that it says air pollution locked down by COVID-19 but not arrested. So I really like it, and kind of I agree with this. So do we really agree that when we see blue sky, that means clean air? We really need to think about and look into, as a scientist, we really need to think about this very seriously and in detailed way. So, and the continuation of this improved air quality, which we still see in August, it's not just because of the lockdown activity, it is also, combination of the monsoon season we are experiencing right now. So what did we let's talk about what did we learn in the air quality lockdown about the air quality. So you have been seeing the tons of publication coming actually every day talking about the reduction in air quality. But when we say reduction in air quality, that means like mostly the papers are talking about NO2 and then PM 2.5 in that order. So we definitely saw a clear reduction in nitrogen dioxide and reduction in PM 2.5, which were obvious, right? Because those are mainly coming from the transport activities which were completely shut down, and then the biomass burning, and then all those activities which were shutting down during the lockdown, we saw the clear impact on the NO2 and PM 2.5. So from that perspective, I have 2 points to make. So positive point, we did observe good air day, like really good air day, with reduced air quality, reduced air pollution in terms of NO2, PM 2.5. But when we deep dive, like we can actually explore the possibility to keep this air quality situation, if not exactly, but we can actually try to keep it nearly. But the second part, I want to make it here, like that is not very positive. But so the reduction was not very uniform. The improved air quality we saw that was not uniform across the region, across the country, across rural, urban. And we also did not see reduction in other pollutants like ozone, which we cannot ignore, which has a serious health impact. So why do we see no uniformity in the reduction of air pollution? The reason is because we have range of sources in our country and other places as well, and some we understand very well, but some we still have to put effort and do the research to understand the sources at local level. So from this, now the question is, can we actually keep this improved air quality with now economy is opening, and how we are going to deal with this? So, and this is an important consideration, as there is an added risk that air pollution will not only return to previous levels, but will likely get worse if environmental regulation will be relaxed for the growth. So considering all those points, do we have quick solution? I think no. We have to really look into the long-term solution. So we need to think holistic, and I'm taking this holistic word and thinking about Kulshrestha sir because he used this term a lot in his conversation. So we need a holistic and sustainable approach, which will require not just the participation from government. Actually, we need a participation from all stakeholders: the government, academia, scientists, think tanks, civil society, and citizen science. So where did we go from this point? In three main categories. So one will be the monitoring and management part. Second will be the policy and government part. And then third, how do we make aware our citizens? So let's talk about the monitoring first. And as we all know that scientists need more and more data to understand and solve the problem. So initiative like, we all aware, whoever is working in air quality, aware of the NCAP program, and which is a very good initiative program to cut down the pollution, PM 2.5 and PM 10. But that program is mainly focusing on cities. And with that, actually, from my experience of the work in India, we cannot ignore the rural air pollution. And for that, I will give an example from my current work. So I'm measuring right now PM 2.5 in northern India using low-cost sensors, covering rural, small cities, big cities, all. And we observe two key points here. I actually wanted, I'm sorry to put a lot of text here, but since I didn't know that I'm going to present, I had to put it. So we observed two key points from the current study. There is one, rural areas are more polluted, and sometimes we see more polluted or equally polluted to the neighboring cities. And also a little lockdown benefit we observe in rural areas. As contrast to the cities, we saw a clear drop down of the PM 2.5 and NO2. So I just wanted to quickly show this result from our data. And this is a low-cost sensor data, so it's not corrected for various parameters for the factors, but still it gives a approximate idea that like these blue lines. So x-axis you are seeing the dates, and y-axis you are seeing the PM 2.5 in microgram per meter cube. And the blue line, the dotted line, is showing the lockdown date started, like when we started, we start the lockdown. So the red color actually showing the rural air quality, and the blue is showing the Varanasi city. So you can see that we had always PM 2.5 more than Varanasi, which we think very polluted, in the neighboring villages as well. And these are not big data set. I mean, I had this graph ready, so I could have shown more, but we can actually see that what I'm saying, it's very well like clear here. And the second graph I wanted to show, like I just plotted this 3 weeks before the day. This is a diagonal variability of PM 2.5 at those different sites, and 3 weeks before. So the upper panel is showing 3 weeks before data, and the below panel is showing 3 weeks after data. And you can see that's like we don't see a clear, like if you're focusing on red point, which is a rural point, rural side, we don't see a very huge jump, drop down after the lockdown. So with that, I also have, it was not my first experience to work in rural area. During my PhD also, I had one site in that Mai village. That is actually my village, named Mai village. And I just quickly wanted to share this result as well. If you focus on the right part of the graph, you see that the maroon part is urban and the green part is rural. And here we are actually seeing the ammonia, not PM 2.5. But ammonia is also an important pollutant to consider because this is a primary pollutant and it contributes in PM 2.5 formation as well. So we can clearly see, without going into this seasonal variation, we can clearly see that, the ammonia concentration were always higher or equal, nearly equal to the urban region. Urban region was actually Delhi. So, yes.
नहीं वो नहीं है इसमें नहीं उनका नहीं वो नहीं है
So speaking about, like I said, I wanted to categorize these into 3 parts: monitoring management. And continuing with the monitoring management part, we need to build the monitoring network, not just to the cities, also consider the villages. And we have to consider the suite of observation method. We cannot just rely on the satellite data only. We cannot just rely on the ground-based measurement only, and not the like other methods. We have to take all the methods together and take the information from all the methods and come up with the solution. So these can also help in increasing the spatial and temporal coverage of air quality data. And that is our ultimate goal, right? Because ultimately that will help building emission inventories at regional level. And the second point I want to make is reduction at source level, which is crucial. And many more studies has been, I have been observing the papers and publications. There are many studies now from India who are focusing on source apportionment study. So by doing the real-time measurement. And one very important point I want to make it here that until now, we always think that, okay, Delhi is polluted and it's coming from neighboring places, but we always have this focus on Delhi and the mega cities like Delhi. But now we have to shift our approach from the city-centric to have an airshed-centric. By saying airshed means that, we have to consider that the pollution, where this pollution coming from, we have to consider the meteorology and the upwind neighboring area, which are actually from where the pollution is coming to Delhi or for that matter any reason. So we cannot just have the approach for the city-centric. We have to have this airshed-centric approach. And also, we have to look beyond PM 2.5 and NOx. Okay, great. PM 2.5 and NOx are very, very important and crucial. But we have other pollutants to consider. Ozone and ammonia are equally, and CO and other long-lived pollutants are equally important to consider when we are actually looking into air quality. And therefore, we cannot look air quality data just by looking at PM 2.5 and NOx. itself, we have to look at the data in tandem with the local emissions, meteorology, and long-range transport. Okay. Since I love ammonia and I have been working on ammonia with Sir and also for my postdoc, I just wanted to quickly show this slide because why ammonia is important. It actually forms particulate matter and create the haze. So we need to look beyond PM2.5 to really see the primary source of PM2.5. Okay. Coming to the mitigation part, we need the mitigation and multi-sectoral level. We cannot just focus on the household or just the transport. Like if we want to target the reduction in air pollution, we have to see like holistic way and focusing on different sectors, being household energy, transport, electricity generation, and so on, other categories as well. So now coming to the policy and government. So what should government policymakers do now? Like, so in my opinion, like I think what because we have the better air quality, we should not relax the program we have already running, like NCAP and other. We should not relax the environmental regulations as part of the, to consider the growth of economy. So we have to have a balance between both. And India is actually making a progress in increasing the clean energy program by providing, providing the fuel delivery program at household, broader rural electrification, ongoing investment in renewable energy. And I just want to quote one study here, which has shown that if all household solid fuels used for cooking, lighting, space heating related activities were converted to clean fuel, that annual PM2.5 standard, which is 14 microgram per meter cube for our standard, that's national entity standard, would be met on an average nationwide. And this is great actually. And that also, we have a co-benefit of that, and that would be accompanied by substantial reduction in associated health impacts. And third point I wanted to make is, so now we talked about the scientists, which they will do the research and analyze the data and talk about the sources. And second, the government will learn from them and will work together to make the policy. But third is the most important and actually very crucial part, which I think we have to think about the citizen. So there is this popular thing coming up these days, that citizen science. So it is actually real. And what is citizen science means? Involving the citizen to actually do not exactly the research, but in the scientific, to make them aware, they can build they can help build awareness in the community. So that is very important, and that will actually can be achieved by the benefits of behavioral change towards the clean environment. So I think that took 10 minutes or more.
More than 10 minutes.
Okay, with that, I wanted to say thank you, and then so we have long way to go. But COVID period gave us opportunity to definitely explore the technology and science part of air quality more rigorously to breathe clean air, or I should say maybe blue sky day. Thank you.
Thank you, Saumya. Very good, wonderful. And you are now becoming mature in air pollution, atmospheric chemistry. I am very happy to see your progress. And now we have next speaker, Dr. Usha Nina. But before that, I had two queries raised by Dr. Abhijit Pathak. One is, Professor Jayaraman, we are concentrating on SO2. Why can't we concentrate on carbon 2? Sulfate is having negative forcing. My second query is, how far Modi data available only 2 times a day for the that you might have read? Can you answer, Professor Jayaraman?
So you were right about the sulfur dioxide part. Yes, sulfate, aerosol point of view, yes, sulfur dioxide and sulfate and it's scattering back. But I don't think the policy is limited to sulfur dioxide. I think obviously the policy includes all pollution. So I'm not really following what exactly means only as
policy for all pollutant is correct. That is true. Another question, Professor Pathak asked to Professor Ishan Kumar, that whether wind is playing any role in increase of CO in eastern areas. Dhanwad and other factors, how much they matter?
No, in our study, because our study was on regional basis. So in regional basis, we did not find wind to be playing a very important role. Actually, if you look at the CO, this Burma region or the Southeast Asia region, this is a major hotspot of carbon monoxide pollution. And we wanted to see whether there is any transport from that region towards the IGP region. And we did not find that to be happening. So, but we tried to also look at this aspect also, we pondered over. But I could not come across any study which has focused on emissions of carbon monoxide from coal mines area. But I think it may be at least playing an important role in the local sense, but not probably over a region as big as the IGP.
Very good. Thank you very much, Professor Ishan Kumar. Now I invite Dr. Usha Nina. She is from School of Environmental Sciences. She was a student here. She is teaching here, but in between she was also serving ICAR. She has a lot of experience in air pollution and plant health. Her Guruji is also there. Professor C.K. Vasne is also there. She did PhD with him. So she is taking care of a greenhouse and other facilities here. She has a lot of projects. Dr. Usha Nina, please. I request you to complete in 5 minutes.
Okay, sir. Thank you, sir.
I am the coordinator for co-coordinator of NVIS activity.
Yeah. Thank you very much to Professor Kulshrestha for giving me this opportunity as an NVIS co-coordinator as well as a subject expertise on this discipline. But before that, I just want to acknowledge this fact that whatever today I am or whatever I am doing in this field is because of Professor C.K. Vasne. He has mentored me and he has only taught us that how we can contribute as an ecologist for improving the air quality of the nation and through scientific perspective. So for this, once again, I am thankful to Professor C.K. Vasne for guiding me and as well as time to time giving me a guidelines also. And
Professor Vasne started environment in India.
Yes, sir.
He is guru of all the gurus.
Yes, sir. And
Can you unmute Professor Vasne?
Hello, sir. Thank you, sir. And with this, I just want to share a brief presentation because my presentation, though my other co-panelists have discussed the air quality with respect to air pollutants, but my presentation is with respect to the role of vegetation in air quality. So I just want to share my presentation. Just please wait for that. I hope my presentation.
It will take 1 minute out of your 5 minutes.
Sir, I'm just finishing this minute.
Usha, share the entire screen.
Okay, sir. Because it is not giving enough.
Yes.
Okay, thank you, sir. Sir, it is not allowing sharing of screen.
Then it should allow. You have to click on allow. Entire screen get allow.
Sir, okay, it is not allowing. I am just doing my presentation like.
No, there is a drop down. There is a drop down menu. Probably you are not seeing that over there. Also, the pop up हो रहा है ना window. So you have to go to the drop down menu and then go to entire screen.
Present now and दे नहीं रहा है तो फिर वैसे ही बोल दो. That is okay. You can say.
That is okay. Sir, I welcome all of you as an NVIS co-coordinator for celebrating this International Day on Clean Air for Blue Skies. And the theme for 2020 is, we all know, that is clean air for all. And I just want to say that as the total biomass of human race, which accounts for just 0.01% on the life of the earth, but we as a human being have manipulated the whole environment of earth. Whereas the other entities which is present on the earth as a life are the plants, which constitute 82%, bacteria 13%, and 5% is anything else. So, and out of those 82% plants, 86% are present on the land biomass. But we human beings are responsible for the loss of this other species on the planet. And among those which we have already lost is 83% of the wild animals we have lost, 80% of marine mammals, and 50% of plants. And those 50% of plants which we have lost, they must have played a critical role in the past evaluation for the maintenance of the air composition, which is essential for the survival of other species. So vegetations play a very critical role in the maintenance of the air quality. They act as a regulator, climate regulator at spatial and temporal scales, as well as they also give us signals. Sometimes they are not only regulating the air quality, they also give us signals of a poor air quality or increasing air pollution levels in any environment as a bioindicator. And so they act as a phytoremediator of the air pollutants also. So it has been estimated that the aerial surfaces of plants is approximately equivalent to 4 into 10 to the power 8 square kilometer on the earth. And on that aerial surface, they provide a habitat for other diverse microorganisms like they home around 10 to the power 26 bacterial species, which indirectly also play a role in the transformation of those air pollutants which got deposited on this aerial surface. But the other aspect which has been more in discussion today, besides this, is that living plant biomass, that is crop residue burning, which is causing the deterioration of air quality, which is more discussed nowadays instead of the positive role that vegetation plays in the maintenance of the air quality. Many studies have estimated that how much quantum of air pollution has been removed by this vegetation. So it has been found out that around 35,429 million pounds of air pollution has been absorbed by the trees, and as well as they also play a role in the carbon dioxide sequestration. So they also act as the climate change. They contribute in the climate change mitigation. They also avoid the storm runoffs and hold the soils also. They prevent the erosion of our fertile top layer of soils, which supports our food productivity. And recently in 2015 also a study which is conducted in UK, they estimated that the UK vegetation, which is present in the UK, they reduce the average annual surface concentration of about 10% for PM2.5 particles, 6% for PM10, and 13% for ozone, and 24% for ammonia, and 30% for sulfur dioxide. Though the UK vegetation has not supported the nitrogen dioxide removal, but there has been a list of vegetation is available which plays a role in the nitrogen dioxide removal also from the atmosphere. So it has been scientifically proven that for the clean air, vegetation plays a very critical role, and we all must have because all must have recognized in our day-to-day life also that wherever we find a lots of vegetation, the quality of air in that region is very well, comparatively very clean, as well as very well as compared to those regions which have a less number of vegetation. And by recognizing the fact and the role of vegetation in climate change, nowadays most of the countries, all over different countries, are actively increasing their green space area by planting trees. And recently, in past 2019, NASA also published a report, and they reported that China and India have increased their green surface area, which is equivalent to the 1/3 of world green surface area. And plant trees are able to absorb this air pollutants as well as regulating the climate in those regions. So this FAST-TECH program to plant millions of trees in cities around the world directly aims at increasing carbon storage, reduction of temperature in those locations where the temperatures are high, storm water control, soil erosion control, and provision for space for recreation, as well as they are also beneficial for human health as well as the crop productivity which is taking place in this field. So this air quality is not only harmful for human health, it is directly harmful to human health as well as indirectly affecting our food security issues also. And in that, the vegetation plays a very critical role. And besides this, nowadays, if we still see most of the technology, most of the new entrepreneurship are appearing, they're using vegetation for mitigating the air pollution issues. So nowadays, the plants provide a nature-based solutions. Plants act as a nature-based solutions and competing with the technologies for mitigating air emissions. And there is a new technology like biosolar loop is there. In this, the solar panels have a minute plant-like microalgae and phytoplankton on solar panel structures installed on land, building, and roof. And this rooftop panels of tiny plants not only increasing the air, cleaning the air quality at the rate of 100 times than the rate of a single tree. So this is then this for indoor air quality also there is a new we can say new technology is in place like Bionic Chandeliers is there. For this Bionic Chandeliers, I have prepared a presentation which I want to share all of you, but I am sorry for that. But this Bionic Chandeliers are a living and breathing structures which purifies the air indoors. And in this chandelier, they fill this microalgae, which not only increasing the oxygen concentration in the indoor air, but also absorbing the air pollutants which is present inside the house. So in this way, lots of plants' potential to remove the pollutants from air has been estimated. And as well as many recommendations has been given for those hotspot regions where the air quality is very low. So now since in India also as well as in other countries, we are greening the planet. But that greening is not taking place, I will say, not taking place scientifically. What Professor Vasni has also told us or taught us that there should be an ecologist must be involved. They will give a proper intervention and they will help us not only in greening of space, but the greening of space will be sustainable also in the future. And they will help the policymaker as well as those who are implementing this greening space policies in the selection of plant species which will make this greening sustainable. And
thank you, Usha. I have to interfere here.
Thank you, sir. Thank you
very much. It's a wonderful that your message. I take that air pollution is not only problem of health, it is a problem of food security. Very good. Wonderful. Now I invite our young holistic leader, Ankita Katoch. She is the lead of activity called quiz. Ankita, she is doing PhD under me on indoor air pollution, especially on reactive nitrogen species. Ankita, please.
Thank you so much, sir. I hope I'm audible.
Yes,
please.
So a very good afternoon to all of you. Thank you a big thanks to my supervisor, Dr. Kulshrestha, for giving me this opportunity. And I'm very happy to see KK sir also. You have taught me, sir, and I've been your student. So thank you so much for being here. And I am also working in the field of plant health and air pollution. So it was really great to listen to Usha ma'am, had such wonderful things to tell, and no doubt this bionic chandeliers are a new concept, and I think it's great that scientists are coming up with such plausible solutions for indoor air pollution as well. So I think a lot of things have been already said, but first of all, I would like to wish everybody a very happy International Day for Blue Skies. 7 September 2020 has been designated as this day for the first time by United Nations. And I am here as a YoHo lead, and under the Holistic Environment YoHo program, we endeavor to celebrate this occasion as an opportunity to address air pollution that threatens our health, food security, and environment. So, like my senior Saumya ma'am also pointed out that this the pre-COVID and post-COVID emissions had changed dramatically, and this COVID period, in fact, provided us a glimpse of cleaner air in several cities across the world. So, and in India, it was also very common. And one good example of clear visibility was observed when the Himalayan foothills in Himachal were easily viewed from a far-off place called Jalandhar in Punjab. So it was a rare sight for people, and these, such incidents were not common earlier. So though we saw that we did enjoy some clean air, but we know that the emissions will gradually increase back to pre-COVID levels as the anthropogenic activities are being resumed across the world. So it is very important that as we battle the current pandemic, we also revisit at the same time how to tackle this persistent air pollution problem. It was mentioned earlier that air quality improvement needs to take all stakeholders on board, be it individuals, civil society, NGOs, private companies, as well as the government. And all of us need to work together in accordance with the national priorities. We can consider curtailing subsidies for fossil fuels and invest more in promoting clean technologies. At a personal level also, I feel that it is very much up to the individuals that they opt for environment-friendly options as a lifestyle change. Because in my opinion, by making conscious personal choices in this direction, every individual can contribute a great deal. And I think it is everyone's responsibility that we do our bit to, ensure a good air quality around us. So we are doing our bit as YoHo team by working in groups and frequently organizing various educational activities and competitions that pertain to holistic environmental themes. And it helps us to reach out to participants from all walks of life, be it undergrad students, school students, research scholars, and also eminent experts like you in the field who take out time to share their research experiences and important views on pressing environmental issues. I think these activities have helped us a great deal in capacity building and sensitizing people, and YoHo is one such great platform. In order to conclude what I'm saying, I would say that the International Day for Blue Skies is another such important opportunity when we can choose to reinstate our efforts in the direction of breathing clean air under a bright blue sky for a sustainable, holistic future. Thank you, everyone. Thank you so much.
Very nice, Ankita. Well done. You have explained YoHo and also your concern about blue sky and clean air. Now, I invite Ms. Swati Singh, Program Officer of ENVIS. We have ENVIS Center, as I told earlier. She will propose a vote of thanks. But before Swati comes on his, I thank all the speakers, all the eminent speakers and attendees, especially Professor C.K. Vaste, who made possible to come. I was not thinking, but when I saw his name on his screen, it was really a surprise. He has been, the force behind all this environment, as Professor Sharma told. Stockholm Conference and other all affiliations. He has, basically from seed to tree, everything he has made the environment in this country. School of Environmental Science started in that purpose only. After that, so many activities and bodies he has, graced, started, chaired, so environmental control, basically he sits on the environmental control driver. So I thank all Dr. Jayaraman, Dr. Jaya Sharma, Professor Ishan Kumar, Dr. Saumya, and Dr. Usha for their contribution, sharing their thoughts and making this possible, because the recommendation we will send to ministry. These are very important one what you have highlighted. Probably one or two may trigger for policymakers and they may be included in further action plan. So with these words, now I invite Swati, please.
Thank you, sir. I hope I'm audible.
Yes.
Hello. Yeah. Thank you for giving me this opportunity to extend vote of thanks on behalf of INVIS to all the eminent speakers and panelists. And I would like to again thank Professor Vasne sir for blessing this occasion. I think it was really kind of him to join us and kind of a blessing for us. And I would like to thank our panelist, Professor Jayaraman sir, for giving such a detailed description, and his study was very useful for the young generation and to take the scenario forward. Thank you, Dr. Sharma sir, Professor Ishan Kumar sir, for your wonderful presentation, and it really helped us understand a lot of nitty-gritties into the issues. And then Miss Dr. Saumya Singh, thank you. Your study was really helpful. How it showed that generally we wonder that cities are more polluted, but understanding that rural areas are much more polluted than the city is a big thing for general public. Professor Umesh Kulshrestha sir for always supporting and for organizing this event. Dr. Usha Nina ma'am, our co-coordinator, for wonderful presentation, and ma'am, it was really informative. And Miss Ankita, thank you so much for putting in your views. And I would like to extend my thanks to all the panelists once again, all the participants on both our platforms here on Google Meet and on Facebook Live. So it is really great that UN has thought of taking this day as a special clean air day for blue sky, because in our childhood we always the first color when we use for coloring a sky is blue, but with time it has really faded away. So I think with this day approach to common man, not only scientific community but common man will be involved in this kind of a venture, and we will make some progress on this and have a blue sky all day. Will be a blue sky day.
Swati, I have a small thing to share over here. Some experience that I had, that from 1995 to 2004 or 2004, I served in Haryana at a place called Hisar. So in Hisar, getting a blue sky was a very common thing. I always used to see blue sky in winters and other. But when I moved to Delhi in 2005, and I saw that the blue sky was not seen because Delhi sky was most of the time hazy. And then we, of course, went on to measure the solar spectral irradiance over Delhi and some rural areas, and we saw the difference. But so the significance of the blue sky I could witness when in the winters, you actually see what is solar dimming in Delhi. That the intensity of solar light is so less. And if you are at a place like Hisar or somewhere in Rajasthan, probably you will see the blue sky and very bright sunshine over there. So I see the relevance of the blue sky over here. Yeah.
It's a reality, yes. Anybody, any comments, feedback, please?
I just wanted to, Swati, I just wanted to make a comment on that. You said you learned, it was good to know that rural air quality is polluted then. So it's not always the case. I just wanted to make it clear that it's not always the case. But for that, like whatever research I have been doing in my PhD with the professor and current project, we found that, rural air quality is polluted, if not more than, but it's equally polluted or nearly polluted to the cities, neighboring city. So, and we need to know more about that, and we need to expand our network, monitoring network, to learn more about rural air quality. That's what my point, I wanted to feedback.
Yeah,
Yeah,
but
you
for
are
blue
right.
sky,
Pollution
we
is a
also,
relative term. Yes. In what reference you are talking about it like that. So
Yeah.
here we are talking about this the panel what aerosol and scattering, de-scattering and relay scattering related thing, and
Yeah.
what are the species contributing to that clear sky, clean air.
Yeah.
So that is what it comes into picture more about the biomass and other things, but that we have to reduce it. Come to clean energy. Yes, sir.
Professor Kulshrestha, I will only say that the ground level ozone monitoring is very important. And to this, the VOCs need to monitor throughout the country because VOC are not being monitored throughout the country. And they have to be, the short-term standard should be there because monitoring
Yes, sir.
of long application is not possible.
Yes,
And
sir.
the PM 2.5 is also not monitored throughout all these stations. Only three parameters they are monitoring throughout country, and PM 2.5 they are not monitoring. So the older station needs revamping. Older station like almost 1,000 stations are there monitoring. Maybe 600, maybe 500, maybe the old one. So they need a relocation because city has developed. So they are not representing the quality data. Cities have expanded. And there is a role in air quality improvement of the town planners and all these things they need to play. Like, for example, in Delhi, close to AIMS, we have a huge construction. So where 5,000 flats are constructed, 10,000 cars, where it will come. So the air quality also needs to be linked with the carrying capacity and other things also. So
Yes, sir. Yes, you are right, sir. EPCA is doing in this term, even with the carrying capacity of air quality in terms of even the cities and or the metro and other. Let me add to this. VOC is not the only cause of ozone. We have done and we have published that ozone increase is related to plastic burning, chlorine and HCl emissions. And those now we have shut down, and now quenching of chlorine, quenching of ozone is not there. So the background level what they were seen in the rural areas, they are seen now in Delhi. So it is not related to VOC chemistry, it is related to chlorine chemistry. So I have added here, I have published, now there is a need, as you rightly said, there is a need to change now the air quality standards. Now please include HCl and chlorine also in that. Now include some more metals, and now don't go to traditional things. We have to modify, we have to redefine the standard. Even I have mentioned in my article that North and South India standard we have to separate out because North India is more dust dominated. Always in the sea in the North India become culprit of that, victim of that standard. That is natural conditions. So North versus South fluxes, AOD values, and if you see, it's a very much quite clear gradient is seen. So based on that, we have to redefine new standards.
Yes. I also found that in critically polluted area, mostly industries are coming up. They are not coming up, which is not the critical area. Severely polluted area, they all come in critical polluted area. So this is another area of concern to what extent we can permit it. But anyway, I enjoyed talking to Jayaraman sir, Ishan Kumar sir, Usha Nina ji, and Saumya Singh. It is very interesting subject to this. Thank you very much.
Thank you. It was nice. It was nice. Very nice audience, very nice speakers we had, and probably some outcome will come as a policy. Let us see in coming few years. Professor Jayaraman, would you like to say?
No, nothing more to add. It was interesting. In fact, I like to really congratulate you, Umesh, because in a very short notice you could make it happen. I do not know in whole of India, probably this is the only one because nobody seems to this day being mentioned in no other word, probably.
Very nice.
You have taken the step. Thank you, Umesh.
Thank you. Very wonderful. Very nice. Yes, please.
Sir, I have one question, please. Sir, I am from Bihar, from Patna, PG Department of Environmental Science and College. Sir, I have some question कि सर ये in lockdown situation, which types of pollutants are found in air, mostly in Delhi region.
Your voice is disturbing. Can you repeat it?
Yes, sir. From Patna, Bihar. I am a student of PG department, environmental science. Sir, I have one question. In lockdown situation, which types of air pollutant is found in Delhi, specific Delhi region?
See, ozone is very much there.
Okay, Ishan Kumar.
Ground level ozone is very much there. Of course, as Saumya had pointed out during her talk, that oxides of nitrogen have gone down significantly, but not so for ozone. Ozone is still prevalent. So that shows that ozone is not just NOx dependent. I mean, VOCs also play a very important role, as Sharmaji, Professor Jitendra Sharma has mentioned, that VOCs also play an important role in ozone chemistry. So sometimes, it depends whether the ozone chemistry is NOx limited or VOC limited. So during the lockdown period, we don't see much decline in the ozone, ground level ozone. Whereas even though the oxides of nitrogen have gone significantly down, and some improvement in aerosols, AOD also we can witness.
Thank you.
Very good. Thank you, Professor Kishan Kumar. His question basically, now mostly all pollutants are down, ozone is increasing for your nutshell. It is like that. Because activities are not there, so only the natural sources are dominating, and only household emissions are there, not any external like aircraft, transport on road. Fossil fuel is almost zero. So from that angle, natural pollutants are always there, particulate matter and ozone, because it is related to photolysis thing. And please note that for ozone, it is not the only NOx and VOC chemistry. It is chlorine chemistry which matters for urban areas, especially where lot of smoke and plastic burning is there. With these words, if there is no question and query, then I thank all of...
Dr. Kulshrestha, one more thing. During lockdown, the ozone, ground level ozone was increased in many of the cities. During lockdown, it was from normal level, it has increased. So it was quite possible it was because of using of tons of sanitizer.
Exactly.
That is also there, but that is minuscule. I tell you, that is not a bigger part. On 16th September, we are organizing Ozone Day, a panel discussion, and all this new knowledge will come, and that day we will share it as a report on website. Thank you very much. Thank you all. Namaste. Stay safe. Bye-bye.
Thank you.
Bye.
Just before, Dr. Malti Goyal, can you unmute Swati? Dr. Malti Goyal is there.
Hello.
Hello, madam. Dr. Malti Goyal. Unmute करोगी स्वाति?
सर आई थिंक उनको अपने एंड पे करना होगा अनम्यूट उनके स्क्रीन पे.
Madam Malti Goyal, if you are listening me, then can you unmute yourself? We want to take your view as well.
Yes.
One way, I think. She's not getting me. Okay. Thank you all. Thank you once again. Namaste.